Okay, so this is 5.6, and most of it is review with a little bit of new stuff. So first, we're going to review synthetic division, but modify it a little bit. We're going to talk about synthetic substitution, which says that you can use synthetic division to find the value of a function. What do we mean by that? Let's take a look. So suppose you're given a function f of x, and you need to find f of 3. Well, we can do this in 3 different ways. One is the way you've been doing it since algebra, is by direct substitution. So you say f of 3 is, and you plug 3 into all the x values. So it's 3 times 3 cubed minus 6 times 3 squared plus 3 minus 11. This is 3 times 27 minus 6 times 9 minus 8, 81 minus 54 minus 8. So finally, f of 3 is 19. Okay, it's fine. It's what we've always done. Well, let's see if there is another way. Okay, let's do the same thing by long division. So when we have f of 3, that means x equals 3, which means you can make that into the term x minus 3, and now that becomes the divisor for our long division. So let's do this by long division. There are no exponents missing, so we can just take it as is. All right, so now 3x cubed over x, that'll be 3x squared. Multiply, change the sign. 3x squared plus x. Divide, we get 3x. So we get 3x squared minus 9x. Change the sign. We get 10x minus 11. 10x divided by x is 10. 10x minus 30. Change the signs. 30 minus 11 is 19, right? We got the same answer as before. Okay, so if we can do it by long division, we can probably do it by synthetic division as well. For synthetic division, remember, we don't need any of the variables. So we don't need to write it as x minus 3. We can just take it as 3 to divide by outside. And here we have the coefficients of f of x, 3, negative 6, 1, negative 11. 3 comes down, 9, 3, 9, 10, 30, 19, right? So what happened? We got the same value of f of 3. We got the same value the 3 ways that we did it. That means we know that whatever the graph looks like, when x is 3, f of x will be 19. Okay, so let's move on. This takes us to the factor theorem, which says when we do polynomial long division and when we get a remainder of 0, the divisor is a factor of the polynomial, and the quotient is called a depressed polynomial, right? And that, that's like the, haha term. Of course, it's not an emotional state. It literally means like pressed down, right? Because that's the polynomial that's pressed down. Okay, so let's take a look here. So what we have to focus on is when we have a polynomial division, when the remainder is 0, that means the divisor is a factor of the polynomial. So let's go ahead and look at example number 2. We're being asked if x minus 3 is a factor of this polynomial. If it is, we have to identify the depressed polynomial and find other factors of the polynomial. Okay, then we have to graph the function. Fabulous. So let's see. If we have x minus 3, that means we can put 3 up here. And I get 1, 4, negative 15, negative 18. 1 comes down, 3, 7, 21, 6, 18, 0. Okay, I did in fact get 0 for the remainder. That means yes, it's a factor. right? Just like 6 is a factor of 24. So when I divide 24 by 6, I should get remainder 0. Right. So now, what does this mean? From here, I get my depressed polynomial. So remember, I started with x cubed. The exponent gets reduced by 1. So now I have 1x squared plus 7x plus 6. So that is the depressed polynomial. And this term here gives me x minus 3. Okay, so that initial equation, that initial polynomial, this, right, we can write it as f of x is equal to x minus 3. And I can factor this and I get x plus 6, x plus 1. Right? So that's my f of x. Right. So we wrote down the depressed polynomial in the blue. We factored it and found the other factors of the polynomial, and now we can graph the function. All right, so what are the zeros here? X equals 3, negative 1, negative 6. And what about the end behavior? So for the end behavior, we have x cubed, which means it's a positive coefficient with an odd power. So it's going to be going to positive infinity on the right and negative infinity to the left. Okay, so let's put in our zeros. It's negative 3. I'm sorry, no, it was positive 3. Negative 1, negative 6, positive 3, 2, 3. So x cubed, it's odd with a positive coefficient. That means it's going to go up over there and down over here. So that means it's going to cross the axis there, turn around, cross the axis there, and that's what it looks like, right? So this is a general sketch. Okay, let's do another one. Given the polynomial and one of its factors, find the remaining factors of the polynomial. Okay, so here is the polynomial. This is one of the factors. We have to find the other ones and then graph. Great. So from x minus 1, we get 1 here. Coefficients of the polynomial go here. 1 comes down, 1, negative 5, 6, 6, 0. That indeed says that it is a factor. All right, so let's pause here for a minute. Since we know this is a factor, if we did not get a 0 here, the math can't be wrong. That just means that I've made an error and I have to go back and double check. Okay, so f of x now can be written as, from that I get x minus 1. The depressed polynomial is x squared minus 5x plus 6. X minus 1, x minus 3, x minus 2. So the zeros are x equals 1, 2, 3. And again, this is x cubed. So it's going to, look like that. So let's see, we have 1, we have 2, we have 3. We know that the end behavior is negative infinity as x approaches negative infinity, and positive infinity as x approaches positive infinity. So that's what it's going to look like. Okay. We can do a little bit more precision here. We can figure out the y-intercept. Right? What is the y-intercept? When x is 0, y equals negative 6. So here I can even go with a little bit more precision. Okay. All right. Next, we're given one polynomial and one factor. We need to find the other factors. So let's do that. It's the same process. From x minus 3, I get 3. The coefficients of the polynomial are 1, minus 1, minus 5, minus 3, and we're always checking that all the exponents are present. 1, we get 3. 2, we get 6. 1, we get 3. 0, which I expected. So I have x minus 3 already, and from here I get x squared plus 2x plus 1. So the other two are x plus 1 squared. Okay. Next one, we're going to have negative 2. The polynomial is 1, 2, minus 1, minus 2. 1 comes down, negative 2, 0, 0, 2, 0. So I get x plus 2, x squared plus 0 minus 1. So that's x plus 2, x plus 1, x minus 1. Awesome. Okay, next one. The approximate number of bald eagle nesting pairs in the US can be modeled by the function p of x, where x is the number of years since 1970. That's important, right? 1970 is t equals 0. Using synthetic substitution, estimate how many nesting pairs of bald eagles can be expected in 2018. All right, so we started at 1970, now it's 2018. So how much is t or x? It's 48. So what I want now, right, since it's p of x, x is the number of years. Now x is 48. So basically I want p of 48. So take a look at where the power of the synthetic division will come in, right? So instead of doing 48 cubed and 48 squared and so on and so forth, you can just do, the synthetic division. For this one, I did graph it and plug in the value, and I got 12,526.37. Okay, so that's about 12,526 bald eagles. Okay, so I did graph that, and I wanted to find the answer as a little bit of a cheat, because I want to show you how, painless it can be with synthetic substitution. So why don't we go ahead and do that now? Let's see if we're going to get that same answer. Okay, so here we're going to put 48. And then this is negative 0.16, 15.83, negative 154.15, 1147.97. The negative 0.16 comes down, and here I get negative 7.68. When you add 8.15, multiply 391.2, 237.05, 11378.4, 12,526.4. Okay, so just to show you, doesn't matter what the polynomial looks like, the process, right? You have to always have faith in the process and the math that goes behind it. All right, thank you very much. See you in class.